we had looked at stationary points in partial differentiation in our previous video, and we look at the case of a maximum point. This time we look at a minimum point. All right. So now we have this curved surface, and here the blue curve, this blue line, is a change in the y-axis. The red line is a change in the x-axis. So the blue is for f of y, the red is for f of x. All right. Now, if we consider that this is the minimum point where the cross, well, you can see it, that's the minimum point there, and you have the tangent to the x, the tangent to the blue line here. This tangent is going to be a horizontal line, horizontal on the xy plane. So in that case, delta f by delta x is equal to 0. The gradient of that tangent is 0. All right. Now, let's consider also the tangent along the x-axis. This is also a horizontal line in the xy plane. So delta f by delta x. Oh, I had put x in the previous derivative, it's y. Delta f by delta y is equal to 0. All right. Now in this case, delta f by delta x is equal to 0. Now, in order to find the location of that stationary point, we want the location. What you need to do is solve both delta f by delta x equals 0 and delta f by delta y equals 0, and it will be a pair of simultaneous equations. So solve them simultaneously to find the location of that stationary point. All right. Now, let's assume you don't know whether it's a minimum or a maximum point as yet. How do you confirm which is which? Now here, if you have a tangent to the f of x or the f of y curve, you have another tangent and so on, you notice the trend here is that the gradient of the tangent is increasing. So in that case, what you have is a case where delta square f by delta y squared is positive. So it is a minimum value in y. Then you talk about the x. What's happening with the x? Because this doesn't mean that the x is also positive, you know, that the delta square by delta square f by delta x square is also positive, you know. One can be positive and the other negative. So let's see what's happening. If you consider moving along the x and finding the gradients of the tangent, you have tangent here, tangent here, tangent here, you see that the gradient of the tangents, as you move in the positive x direction, the gradient of the tangent are increasing. So delta squared f by delta x squared will also be positive. So delta squared f by delta x squared positive. So that shows that there is a minimum value in x. Now, as long as both delta squared f by delta x squared and delta squared f by delta y squared are positive, then what you have is a minimum point. All right, so that's what you have there. So that shows how to get the location and the nature of this stationary point. So in the previous video, we saw that when both of them are negative, both second derivatives are negative, then we have a maximum point. When both second derivatives are positive, then we have a minimum point. Now, the question is, what happened when one is positive and the other negative? Well, that's what we're going to look at in our next video.